The Big Freeze, how the universe will end and why it's terrifying. It begins with a silence so complete, so absolute, that even the memory of sound seems alien. A silence that stretches across trillions of years, beyond the lifespan of stars, beyond the reach of galaxies, beyond anything the human mind was ever built to comprehend. In that distant future, long after the last light has faded and every star has burned its final breath, the universe enters a phase so cold and so vast, it makes every extinction, every cosmic disaster, every apocalypse in our imagination feel small. This is the Big Freeze, the slow, unstoppable death of everything. And what makes it terrifying is not fire, not collision, not explosion, but time itself. Time stretched so far that decay becomes destiny, and the universe, once vibrant and violent and full of creation, falls into a state of eternal stillness. But to understand how the cosmos ends, we must first understand how it lives, how it changes, and how every star born today is already writing a tiny part of its funeral. The story of the Big Freeze is not a dramatic explosion or a cataclysmic collapse. It is a story of gradual loss, of heat, of energy, of structure, of meaning. It is the slow draining of the cosmic battery. Right now, the universe is expanding, and with every passing second, that expansion accelerates, stretching space itself like an invisible fabric pulled taut by a force we still don't fully understand. Dark energy, mysterious, powerful, and indifferent, is driving galaxies farther apart, making the universe larger but also colder. In hundreds of billions of years, the night sky as we know it will disappear. The Milky Way, Andromeda, and a handful of nearby galaxies will merge into a single island universe, while every other galaxy drifts so far away that their light will never reach us again. Future civilizations will live under a sky almost empty, unable to see the past, disconnected from the very history of creation. But the Big Freeze only becomes truly terrifying when we zoom even farther ahead, to the era when star formation stops entirely. There will come a time when the universe runs out of the raw material needed to make new stars. Hydrogen becomes scarce, nebulae fade, the birthplaces of light go dark. One by one, the stars that exist today, tens of billions of trillions of them, will exhaust their fuel. Red dwarfs, the longest-lived stars in the cosmos, will remain as the final flickers of warmth, burning dimly for trillions of years. Eventually, even they will cool into black dwarfs, cold, dead spheres of carbon and oxygen floating silently in a sea of endless night. When the last star goes dark, the universe officially enters the degenerate era, an age where almost nothing happens because almost nothing can. In this distant future, the universe will not be a place of light, but a graveyard of remnants. White dwarfs cooling into black dwarfs. Neutron stars spinning slower and slower until they fall silent. Black holes silently swallowing whatever passes close enough, feeding not on galaxies or stars, but on the leftover debris of a universe that has forgotten how to shine. Collisions become rarer as space expands. Temperatures drop toward absolute zero. Even molecules, the building blocks of chemistry, struggle to exist as energy becomes scarce. And yet, somehow, the story gets even darker from here. The Big Freeze becomes truly haunting when we move beyond the fading of stars and step into the era where even the leftovers of the universe begin to fall apart. At this stage, black holes dominate the cosmic landscape, scattered like ancient monuments in a wasteland of thinning particles and near-empty space. These black holes, once engines of destruction and transformation, now sit quietly, their surroundings drained of anything meaningful to consume. For an unimaginable span of time, they remain as the last powerful structures in the cosmos, each one holding memories of entire galaxies it once fed on. But even they are not eternal. Hawking radiation, the slow leak of energy through quantum effects, begins to chip away at them, atom by atom, at a pace so slow that the human mind cannot process it as time. Supermassive black holes will take around a googol years to evaporate. That is a 1 with 100 zeros behind it. A number so far beyond comprehension that our language breaks long before the timeline does. And when the final black hole eventually shrinks, glows briefly, and vanishes, the universe crosses a point of no return. It becomes a place with no stars, no galaxies, no planets, no black holes. Only drifting particles and cold radiation spread thinly across a space that keeps expanding forever. What remains is an era that feels almost like an afterthought of creation. The universe is now larger than anything we could ever map, colder than any temperature we can reproduce, and quieter than any silence we have ever known. Particles drift through space without colliding. Distances between them grow so vast that interaction becomes almost impossible. A proton could float for billions of light years without meeting anything at all. And here, in this lonely expanse, something even more unsettling begins: the gradual decay of matter itself. Current physics suggests that protons, the particles that make up atoms, the particles that make up us, may not last forever. If they eventually decay, then every atom in the universe will break down, turning what was once solid and structured into a thin mist of radiation. If this decay happens, the universe becomes not just dark and cold, but structurally empty. Nothing larger than subatomic particles can survive. No stars, no planets, no molecules, no atoms. Just a thinning fog of particles stretched across a space that refuses to stop growing. By this point, the timeline has reached numbers that feel meaningless. Trillions of years gave way to quadrillions, which gave way to timescales so enormous they leave no imprint on our imagination. And yet the big freeze still continues, grinding forward with no destination, no dramatic finale, no last explosion. Instead, the universe fades like an old photograph left under sunlight for too long, colors draining, details disappearing, until only the faintest outline remains. The temperature creeps closer to absolute zero, the coldest temperature allowed by the laws of physics. Motion slows, energy thins. Any event that could be called something happening becomes rarer and rarer, until the universe reaches a point where nothing changes in any measurable way. Every clock has stopped, not because they broke, but because time itself has lost anything to measure. What makes this ending so unsettling is how quiet it is. Not a collapse, not a firestorm, just an endless spreading out, a stretching that never ends. A slow suffocation of creation. A universe that once gave birth to stars, galaxies, black holes, life, and thought eventually turns into a desert where even the concept of change disappears.
This is the heat death of the universe, a place where entropy has reached its maximum, where energy is too evenly spread to create anything meaningful, where motion itself becomes pointless. It's the final chapter not written with violence, but with absence, not with destruction, but with silence. A silence so complete that calling it silence feels inadequate, because silence still implies the possibility of sound returning. Here, it never will. Yet even in this cold, stretched-out darkness, a question lingers like the faintest vibration. Is this truly the end, or merely the end of this version of the universe? Some physicists suggest that even in the most desolate conditions, quantum fluctuations, tiny, unpredictable tremors in the fabric of space, could spark something new. Perhaps a bubble of energy could appear from nothing. Perhaps a new universe could form inside the ruins of the old one. If so, then our universe would not die in darkness but give way to something beyond our comprehension, like a seed germinating in the coldest soil imaginable. But these are ideas we may never confirm. Ideas whispered by mathematics rather than observation. Ideas that remind us that the universe still holds its secrets tightly, even at the edge of time. As we push further into this unsettling future, the universe enters what physicists sometimes call the era of eternal thinning, a stage so stretched and so drained that even the word empty no longer captures its condition. In the earlier ages of the cosmos, emptiness still had structure. Quantum fields humming with energy, particles flickering in and out of existence, gravity weaving subtle patterns across space. But in the deep freeze, when the last black hole has evaporated and the last atom has fallen apart, even that faint cosmic hum begins to fade. Space becomes a quiet plane of near-zero energy. Quantum fluctuations weaken but never fully disappear, like the last shivers of a dying flame trying to stay alive against an endless night. The laws of physics continue to operate, but they no longer have anything meaningful to act upon. Gravity becomes irrelevant because there is nothing left to pull together. Electromagnetic forces have no atoms to influence. Even the passage of time becomes nearly abstract because time is defined by change, and change has practically stopped. This is not a universe dying in fire or chaos. It is a universe dissolving into stillness, stretched so thin that it barely holds an identity at all. Yet, for all its silence, this final era forces us to confront something profound about the nature of existence. Throughout all of cosmic history, creation and destruction were two sides of the same process. Stars were born because dust clouds collapsed. Galaxies collided and reshaped themselves into new forms. Even black holes, which we imagine as cosmic devourers, played a role in structure and growth by sculpting galaxies around them. But the Big Freeze marks the end of that balance. Creation stops permanently. Destruction slows until it becomes little more than a distant memory. What remains is a universe without purpose or direction, unless, hidden deep within that quiet, another process waits to emerge. Some theories propose that even in this thin, cold future, rare events could still occur. For instance, a random quantum fluctuation might briefly create a particle, or perhaps even a tiny black hole that would evaporate almost instantly. These events would be so scarce that the universe might wait unimaginable spans of time between each one, like a desert waiting eons for a single grain of dust to shift. But they would still be there, faint reminders that the laws of physics never fully stop. It is here that some scientists introduce one of the most haunting ideas in modern cosmology: the possibility that the universe could spontaneously restart itself from within the quiet of the heat death. In certain models, a quantum fluctuation could generate a tiny region of extremely high energy, high enough to behave like the early universe did during the first split second after the Big Bang. If this region expanded rapidly enough, it could form a new space-time bubble, separate from the dead universe around it. Inside that bubble, a new cosmic timeline would begin, complete with fresh laws of physics, fresh particles, and a fresh burst of light. To observers inside that newborn bubble, it would look like a new universe beginning from nothing. They would never know that beyond the walls of their cosmic horizon lies the quiet, frozen corpse of an older universe that lived and died long before theirs began. This possibility turns the Big Freeze from an ending into a transition. Not a cosmic death, but a cosmic metamorphosis so slow and subtle that no civilization could ever witness it directly. But whether or not new universes emerge, the original universe, our universe, continues its drift toward deeper and deeper cold. Once all energy is spread evenly, once every source of warmth is gone, and once every structure has decayed, the cosmos becomes indistinguishable from a quiet mathematical space. Nothing moves, nothing forms, and nothing changes. In this distant epoch, even the idea of direction loses meaning, because direction requires a frame of reference, something to measure against, and the universe no longer offers one. The great cosmic web that once connected galaxies, stars, and planets has unraveled into a thin, silent fog. Every memory of the universe's earlier vibrancy, every trace of the age of stars, every echo of life and thought is gone. What remains is not a graveyard but a blank sheet, waiting for something that may never come. And yet, when we think about this final picture, something important becomes clear. The terror of the Big Freeze does not come from destruction, but from absence. Humanity has always feared endings that carry violence, because violence is familiar. But this ending offers no drama, no final burst, no last spark of defiance. It is simply the slow fading of light, the quiet stretching of space, the thinning of energy, until the universe becomes a cold whisper drifting across an infinite void. For all its scale and grandeur, the cosmos ends not with fire, but with silence, and that silence, more than anything else, reveals the fragility of everything that ever lived, thought, or tried to understand its place in the stars. As the universe sinks deeper into this quiet and near-motionless future, we reach a point where even concepts like past and future begin to blur, not because time has vanished, but because time no longer has anything to measure itself against. In the universe we know today, time is marked by motion and change. Stars burn, planets orbit, galaxies collide, particles interact, and energy flows from one place to another. But in the frozen epochs of the far future, when all meaningful motion has ceased and every gradient of temperature has flattened, the very markers that distinguish one moment from the next evaporate. The cosmos becomes a place where time exists only as a mathematical formality, not as something that produces events. If a civilization somehow survived into this era, and the laws of physics strongly suggest none could, it would witness a universe that behaves less like a dynamic system and more like an endless pause, a cosmic still frame stretched across an unbounded darkness. Nothing within it would resemble the living universe that once sparked stars, formed worlds, and gave rise to beings capable of questioning their cosmic fate. And yet, even in this cold, thin void, the foundation of reality remains. Quantum fields lie dormant but not extinguished, stretched across the cosmos like quiet, invisible seas. Occasionally, randomly, without intention or pattern, they ripple. These ripples, quantum fluctuations, are the last events that can happen in a dead universe. A single particle might flicker into existence and vanish again almost immediately. A photon might appear from the vacuum, travel for billions of years without meeting anything at all, and then fade into the background radiation. These tiny sparks of physics do not warm the universe or change its fate, but they serve as the final reminder that beneath the silence lies the machinery of existence itself. The universe is quiet, but not off. It is still governed by laws, still underpinned by fields, still capable of producing the smallest acts of randomness, even if they have no consequences. This strange twilight, this era where the universe has become a nearly featureless expanse yet retains faint whispers of structure, is one of the most unsettling stages in cosmic history, because it forces us to imagine existence stripped of everything we associate with life, light, or meaning. As time stretches further, beyond any scale we use today, the universe becomes so vast and empty that even these tiny fluctuations grow more infrequent. Distances between particles become effectively infinite. With no structures left to measure, no energy to harness, and no matter to interact, the universe enters a form of deep stasis. It is not absolute nothingness, because empty space itself is still something, but it is the closest the universe can physically get to nothingness without ceasing to exist. And it is here, in this almost featureless expanse, that physicists confront the ultimate question. Does the universe simply remain like this forever, or does something unexpected happen next? The The Big Freeze is often described as the final state, yet every time humans have labeled something as final in the past, the universe has revealed another layer beyond it. We once thought the Milky Way was the entire cosmos. We once thought time had a beginning and an end fixed neatly around human history. We once believed stars were eternal. Each assumption was overturned by deeper understanding. So when scientists attempt to describe the universe 10 to the power of 100 years from now, they do so with a mixture of confidence and humility, because this far future lies so beyond observation that only mathematics can guide us. It is here that a surprising idea emerges. The heat death may not be a static tomb but a staging ground for something new. In certain interpretations of quantum mechanics and inflationary theory, empty space is unstable. Even the calmest vacuum carries the potential to erupt into a new bubble of high-energy conditions. If such a bubble were to form, extremely rarely, arising from a fluctuation so improbable that it may take longer than the age of countless frozen universes combined, it could inflate into a new cosmos. To the outside, to the old universe, the bubble might exist as a tiny region of warped spacetime. But to the inside, to whatever emerges within it, it would feel like a brand new universe with its own laws of physics, its own timeline, its own possibilities. In this view, the Big Freeze does not destroy everything. It simply ends the chapter of our universe, while opening the potential for another to begin, born not from a singularity, but from the cold ashes of a universe that slowly quieted over unimaginable stretches of time. But whether or not new universes emerge, the fate of our universe remains the same. It decays not with fire but with fading. The stars that once lit the void with brilliance go dark. The galaxies that once thrived with rotation and structure dissolve. The black holes that once commanded awe through their gravity evaporate. The atoms that once formed life break apart. The very idea of history fades because nothing remains to record it. And so, the universe does not end in a moment but stretches its ending across a timescale so vast that language itself fails to capture it. The Big Freeze is terrifying not because of destruction, but because of erosion, the erosion of heat, the erosion of structure, the erosion of time. It is a reminder that even the grandest creation can fade into stillness, and that the universe we see around us, vibrant and full of movement, is only a temporary spark in a cosmic timeline that extends far beyond our own imagination as the universe stretches further toward this silent horizon. The Big Freeze transforms from a distant scientific prediction into a vision of cosmic isolation so complete that it challenges our deepest assumptions about existence itself. At this point, the expansion of space has carried every remaining particle so far apart that even the concept of location becomes slippery. A lone photon, released perhaps trillions of years earlier, might travel an unimaginable distance only to find nothing. No atom to collide with, no dust grain to scatter against, no field strong enough to alter its path. It simply moves, endlessly, across a canvas that never ends. This is the era where the universe loses all sense of identity. In the past, the cosmos was rich with landmarks. Clusters of galaxies, luminous stars, swirling nebulae, planets, moons, and the delicate pattern of cosmic filaments stretching across billions of light years. But now, in this nearly structureless expanse, those landmarks have dissolved. Even gravitational influence, once the architect of galaxies and the sculptor of cosmic architecture, becomes so diluted that it can no longer bind anything together. Without matter and without energy gradients, the universe becomes unrecognizably flat, not geometrically, but physically. Flat in emotion, flat in texture, flat in story, a place where nothing happens because nothing is left that can happen. Although the story appears finished on the surface, this stage forces us to confront something far more profound. The universe was once a machine that produced complexity, but it has now become a machine that prevents it. For billions of years, the cosmos excelled at building stars, molecules, life, consciousness. But entropy, the quiet force guiding every process, has slowly taken back everything it allowed to exist in the first place. In the Big Freeze, entropy stands triumphant. All useful energy has dispersed. No engine can run. No star can ignite. No organism can metabolize. Even thought itself becomes impossible because thought requires energy, gradients, chemistry, all of which the universe has spent and scattered. What remains is a cosmic afterlife, not for beings but for space itself, a place where the rules still apply, yet nothing within them has the ability to act. For a universe that once brimmed with potential, this final state is haunting because it is perfect stillness, a stillness that grows deeper with each passing aeon. And still, physics refuses to let the story end cleanly. Even when the universe reaches this ultra-cold horizon, certain rare and improbable processes continue to whisper through the void. One of the most unsettling among them is known as the quantum recurrence idea, the proposition that given enough time, even the most unlikely fluctuations might occur, including the spontaneous formation of complex structures or entire new universes. These events are so improbable that they require timescales vastly beyond Google years, timescales that dwarf even the age of the heat-death universe. Yet, in a place where time has effectively become infinite, even the rarest outcomes gain a non-zero chance of occurring. This possibility means that the Big Freeze is not simply an ending but a horizon where reality becomes unmoored from all familiar patterns. An eternity of cold does not necessarily mean an eternity of nothing happening. It means an eternity where the strangest events imaginable could occur, though separated by intervals so vast that no consciousness could witness more than a single flicker before fading into the cosmic dark. In the deep calm of this unimaginable future, we are forced to confront the irony that the universe's fate mirrors its beginning. At the birth of the cosmos, everything was too hot, too dense, too energetic for structure to exist. In its final state, everything is too cold, too diffuse, too drained of energy for structure to exist. Both extremes, the raging heat of the birth and the silent cold of the death, share the same outcome: simplicity. No galaxies, no stars, no planets, no life. The universe begins and ends with a quiet form of simplicity, separated only by a middle chapter where complexity briefly rose, blossomed, struggled, and eventually faded. And yet, for all its bleakness, there is something strangely poetic about this symmetry. It suggests that the universe's life cycle, however vast, may be governed by principles that operate far beyond our human sense of meaning. Maybe the cosmos doesn't need drama to be profound. Maybe the silence at the end is not a tragedy but a natural final note, the soft exhale after trillions of years of motion. As the universe slides deeper into the era of decay, the once brilliant galaxies that lit up the cosmos fade into cold, silent smudges scattered across an ever-expanding void. The Milky Way itself becomes a lonely island adrift in a dark ocean that no longer carries the glow of distant stars. Every remaining source of warmth, every lingering spark of fusion, every nuclear furnace that once sculpted the elements of life begins to shut down one by one. Stars grow old, sputter, and collapse into the quiet finality of white dwarfs, embers of a universe that used to burn with unimaginable fire. These white dwarfs cool over trillions of years, fading into black dwarfs, dead stars that emit no light, no heat, nothing. Gravity loosens its grip. Solar systems fall apart. Planets drift into nowhere. The night sky becomes darker than any human imagination can grasp, an eternal blackness unbroken by starlight. And still, the expansion continues, stretching space so brutally that even the memory of warmth becomes a distant echo. Black holes, those cosmic monsters that once devoured stars, become the final rulers of a dying universe, lurking in the shadows like ancient predators waiting out the last breaths of creation. But even they are not immortal. Over unimaginable timescales, they begin to evaporate through Hawking radiation, slowly leaking away their mass until they shrink into nothing. One by one, the titans collapse into brief flashes of energy and disappear forever. When the last black hole dies, the universe is left in its most terrifying form. Cold, empty, silent, and eternally expanding. No light, no stars, no galaxies, no atoms forming anything meaningful. Just thin, lonely particles scattered across an infinite darkness where nothing new can ever happen again. This is the Big Freeze. Not an explosion, not a collapse, but a slow, merciless fading into absolute zero, a cosmic death by silence. And what makes it truly terrifying isn't just the emptiness waiting at the end. It's the realization that every beautiful moment in cosmic history, every star born, every galaxy formed, every world that ever hosted life, was only temporary. A brief flash of order in a universe destined for darkness. The Big Freeze isn't just the end of everything. It's the final reminder that the universe doesn't die with a scream. It dies with a whisper. As the timeline stretches beyond anything the human mind is built to comprehend, the universe enters a phase where even the laws of physics seem tired. The temperature sinks so close to absolute zero that motion itself nearly stops. Molecules can no longer vibrate. Atoms barely cling together. Chemistry becomes impossible. The last sparks of interaction that once fueled stars, planets, and life fade into a dull, endless stillness. The cosmos, once bursting with color and sound and light, becomes a graveyard of frozen particles drifting endlessly in an ever-growing void. Even the background radiation, the faint afterglow of the Big Bang, dilutes into near-nothingness, stretched thin across a space so large that it becomes indistinguishable from pure emptiness. Time still marches forward, but nothing meaningful happens within it. The universe continues to exist, but without purpose, activity, or structure. It has become an infinite canvas with no ink left to paint its story. Dark energy, the invisible force pulling everything apart, still works in the background like a quiet executioner, ensuring that no particles ever come together again. Every trillion years of expansion erases more of the universe's past, stretching distances so brutally that even the concept of neighboring particles becomes meaningless. The cosmos is no longer a place. It's a cold mathematical space where matter is thinly sprinkled like dust lost in eternity. And in this frozen dark, there are no new stars to ignite, no galaxies to form, no black holes left to collapse. The last remnants of the universe drift farther and farther apart until interaction becomes physically impossible. Existence becomes a word with no meaning, and yet the universe keeps expanding. It doesn't stop at emptiness. It pushes beyond it, pulling itself wider with each passing aeon until the very idea of scale breaks down. Without light, without energy, without mass doing anything at all, space becomes nothing more than geometry expanding into oblivion. This is the final, bleak frontier, the point where the universe no longer resembles the place that once nurtured galaxies, supernovas, and life. Instead, it becomes an endless, silent, frozen desert where no future can ever begin, no past can be remembered, and no present can unfold. The Big Freeze is not just the end of the universe. It's the slow erasure of everything that ever made it beautiful. As the universe drifts deeper into this era of eternal darkness, the last structures that once defied entropy finally surrender. The most resilient objects, the cold remnants of dead stars, the loneliest planets wandering without suns, the iron cores of collapsed worlds, crumble at the atomic level as proton decay begins its slow, merciless work. Over quadrillions upon quadrillions of years, the very building blocks of matter begin to rot away, dissolving into radiation so faint it barely qualifies as existence. What was once solid becomes ghostly, What was once matter becomes whispers of energy sliding through an endless void. Nothing remains stable. Nothing remains permanent. Even the particles that once formed life, consciousness, and memories eventually fall apart, fragmenting into nothingness as the universe patiently strips away every last trace of structure. Black holes, the titans of destruction that once feasted on stars and swallowed entire galaxies, continue their lonely vigil in the dark, but they, too, are doomed. Through Hawking radiation, they leak away mass bit by bit, glowing faintly like dying embers in a wind that never stops blowing. The largest black holes hold on the longest, but even they cannot escape the final entropy tax. One by one, over unimaginable stretches of time, they shrink, destabilize, and evaporate in silent puffs of fading heat. With their deaths, the cosmos loses its last engines of complexity. No more gravitational monsters, no more cosmic fireworks. The universe is now a place where not even a black hole can survive. And after the final black hole releases its last whisper of radiation into the void, the universe enters a phase so empty that even emptiness seems too full a word to describe it. This is the ultimate stillness. A cosmos without energy gradients, without motion, without contrast, without purpose. Thermodynamics reaches its cold, inevitable conclusion, perfect equilibrium. No heat can flow, no work can be done, no process can occur. It is a universe that has reached maximum entropy, a place where time still exists but has nothing left to measure. This is the big freeze, not as a dramatic explosion but as a quiet annihilation, the slow extinguishing of everything that ever was. Not with fire, but with silence. Not with collapse, but with unraveling. A universe that lived through chaos and creation, through stars and galaxies and civilizations, fades into a cosmic winter that does not end. A winter so vast, so absolute, that even eternity feels small compared to it. And in this frozen infinity, the final truth becomes painfully clear. The universe does not die in a moment. It dies in a whisper stretched across forever. Yet even in this unimaginable stillness, the concept of forever continues to stretch outward, because the big freeze is not a single event but an endless descent, an eternal slowing, cooling, and fading that proceeds long after the last meaningful change has occurred. The universe becomes a vast, featureless ocean of near absolute zero darkness where particles rarely interact, drifting through distances so inconceivably large that they might as well be alone for all of time. Space itself keeps expanding, pulling everything farther apart, thinning out the already threadbare fabric of existence until even the idea of distance loses coherence. What remains is not a universe as we understand it, but a mathematical shadow of one. A silent, ever-expanding vacuum populated by radiation so weak it barely qualifies as being real. Over time, even that radiation redshifts into nothingness, stretched by the expansion of space-time until its wavelength exceeds the scale of galaxies, then clusters, then the observable cosmos itself. In this ultimate epoch, the universe becomes a canvas without color, texture, or structure. With no stars to illuminate it, no galaxies to arrange it, no atoms to build with, reality becomes a dark, thinning mist of near-nothing where the very laws of physics remain but have nothing left to act upon. And yet, in this cold twilight that spans incomprehensible stretches of time, entropy still increases, slowly, patiently, mechanically, because entropy is simply the universe's tendency to exhaust every possibility, to smooth out every difference, to eliminate every contrast until there is no here or there, no before or after, no change to define the passage of time. Thermodynamics does not stop when the stars go out. It continues its quiet conquest until all that exists is uniform, eternal stillness. This fate is terrifying not because it is explosive or violent, but because it is inevitable, built into the very mechanics of the cosmos. The Big Freeze is the final chapter that every star writes, every black hole whispers, every atom hints at. That warmth is temporary, structure is temporary, existence itself is temporary. Even the grandest galaxies and brightest suns are just momentary sparks in a universe destined not for fire but for fading. And in the unimaginable quiet at the end of all things, the universe becomes a monument to impermanence, a reminder that everything, every life, every world, every light, was a brief defiance against the cold. If there is anything more chilling than the end of the universe, it is the realization that the universe ends not because something destroys it, but because it simply runs out of energy to continue existing in any meaningful way. The fire goes out, the warmth fades, and what remains is a cosmic winter without memory, without motion, and without dawn. As the universe sinks deeper into this cosmic winter, the very concept of time begins to lose its significance, because time is measured through change, and when change becomes so rare, so imperceivably slow, it barely registers against the backdrop of eternity. Matter, too, becomes a stranger to itself. Protons may begin to decay, dissolving into showers of lighter particles that drift endlessly through the freezing dark. Galaxies have long since dissolved, stars have long since died, and now even the atomic building blocks of reality begin to unravel. Over spans of time so incomprehensibly vast they dwarf the entire history of the universe, matter itself becomes a ghost. The last remnants of structure, cold rocks, wandering planets, derelict stellar corpses, crumble into radiation, adding to the thin, fading whisper of energy that stretches across a cosmos now too large, too empty, too cold to even notice it exists. Black holes remain the final architects of change, but even they are not immortal. Hawking radiation slowly gnaws away at their mass, draining them over quadrillions upon quadrillions of years until they too evaporate in brief, weak flashes of heat that flicker meaninglessly in the infinite night. In the era that follows, only particles of unfathomable loneliness move through the void. Stray electrons, stretched radiation, and the ghostly remains of evaporated black holes. There are no structures left to collapse, no forces left to balance, no light left to travel. Reality has become a vast cemetery of once great processes, a heat-dead wilderness where entropy has reached its absolute command. The universe no longer evolves, no longer transforms, no longer participates in anything that resembles the dynamism it once held. It becomes, in every sense, a stillborn infinity. Space keeps expanding, but expansion no longer matters because nothing within it reacts to the stretching. It is an expansion of absence, a growth of emptiness, a swelling of the void that now defines everything. And as the last quanta of useful energy dissolve into uniformity, the universe takes on a strange and haunting identity. It becomes a perfect equilibrium, a state so uniform, so balanced, that nothing within it can ever change again. This is the final form of the Big Freeze. Not destruction, but absolute quietude. Not a violent death, but the complete dissipation of everything that once made the universe vibrant. The cosmos ends not in fire, but in stillness. Not with an explosion, but with a whisper that fades until it becomes a silence stretching across eternity. And in that eternal silence lies the greatest cosmic truth, that everything beautiful, everything bright, everything alive in the universe existed only because it was fleeting. Stars shone because they were burning their fuel. Galaxies formed because matter was clumping. Life emerged because energy flowed. The universe was dynamic because it was temporary. And now, in the unbroken quiet of the far future, what remains is not a tragedy but a confirmation of what we always suspected. That even the universe obeys the rule of impermanence. And so, as the universe settles into its final, frozen stillness, what remains is a silent expanse that no longer remembers it was once filled with stars, colors, motion, and life. The big freeze leaves behind a cosmos that has stretched itself beyond meaning. A place where even the smallest flicker of warmth has been drained across distances so vast they cannot be measured in anything familiar to us. This cold, empty future is not dramatic, not violent, not marked by any final explosion. It is defined instead by the slow fading of everything that ever mattered. And yet, there is something strangely powerful in that picture. All the brilliance we see today, all the galaxies scattered across the night sky, all the lives and minds that have ever stared upward with questions. These existed in a narrow window between nothingness and nothingness, a moment when the universe was young enough to create structure but old enough to let it thrive. Our time is not insignificant because it is temporary. It is extraordinary because it exists at all. The Big Freeze reminds us that the universe did not have to be a place where stars are born, planets form, chemistry dances, or consciousness wakes up. But for a brief chapter in the immeasurable lifespan of reality, all of that happened. And we are living in that chapter. We are witnessing the universe while it is still bright, still warm, still alive with motion and possibility. One day, trillions upon trillions of years beyond anything our minds can stretch toward, the cosmos will fall quiet. But tonight, as we look up, the universe is still singing. The galaxies are still shining. And for now, while this fragile moment lasts, we are here to see it.